It's George, and I'm back again. And I'm here to show you a couple things. Okay, we're going to go to the picture. And this is for all the experts. The experts, okay? Looks like a rock. Okay? Now we're going to stay on the picture just for a second and give a person a chance to guess whether this is a meteorite or an earth rock. Okay, now that you've had a chance to guess, let's find out who guessed right and who guessed wrong. Okay, there's the rock. Okay, now let's get a real good. Here comes the third picture, real close up of it. Ta-da! Look at all that metal. All that metal was inside of this rock. Now, how are you going to tell if that is a meteorite by looking at that picture? And this is the problem that I have with looking at pictures. This is the problem that I have with looking at pictures, and people don't get it. People don't get it because you could send a picture of a rock that would be a meteorite if it has all the right, but this doesn't have a lot of what they say. This doesn't really have fingerprints and this and that and this and that. But you sand off a little bit and you come up with that. That is metal. Now, whoever answered that this is an earth rock needs to go back to school. And that's all I have to say about that. Now, how do the whole rocks like this? How does a whole rock like this make it to Earth? Well, I'm going to explain something here, okay? If you are an expert, you should know this. Okay, neon is colorless and odorless. Okay, it is in the atmosphere, but not in large amounts. But if you look up noctilucent clouds, that can, let's say, increase the percentage of neon in the atmosphere. This is something for people need to look up. Okay, you need to look up neon, you need to look up noctilucent clouds, and then you need to look up liquid air and liquid oxygen. Okay, the air and the oxygen, which is in the lower part of the atmosphere, can liquefy under the right conditions. Okay, now liquid oxygen is more dense than regular oxygen. Liquid air is denser than regular air. Okay, so what is that going to do? That's going to make it denser. It's going to slow things down. So instead of these things coming in at speeds when they come out of the mesosphere, they're going to go even slower and slower and slower. And then pretty soon you get this. It's just going to drop to the earth. Now, why people can't figure this stuff out, it's beyond me. I'm not an expert. But I looked all this stuff up and I pieced all this stuff together. And I'm telling you, and the Hoba meteorite that never left the crater is probably this scenario right here. It came in after one of those heavy meteor showers, and the density of everything, because the air was liquefied and the oxygen was liquefied, it slowed it down, and that's why it didn't leave a crater. Now, whether you people want to believe me or not, that's your choice. But I'm finding all this good stuff out, and all the experts post this information out there for me to look at. And like I said, This is metal, okay? This is a meteorite. That is a meteorite, okay? And the only thing that I have to say about that is the boss fades back, swoosh, and that's the game. Enough said.